Welcome to the DIY Honda Garage channel. The DTC P0716 refers to a problem identified in the input turbine speed sensor A circuit related to its range and performance. This particular sensor plays a crucial role in the vehicle's continuously variable transmission (CVT) system by measuring the speed of the torque converter turbine. Accurate readings from this sensor are essential for the engine control module (ECM) to optimize power delivery and fuel efficiency, as well as manage shifting operations smoothly. This DTC signifies an electrical issue in the circuit rather than a mechanical problem within the transmission. The positioning of the input turbine speed sensor is typically found within the transmission assembly, usually near the torque converter. To accurately diagnose this DTC, technicians must carefully assess the electrical connections and data outputs associated with this sensor. Final repair verification is crucial to confirm that the issue related to DTC P0716 has been resolved. This step begins with turning the ignition switch to the on position or pressing the engine start-stop button. Subsequent to this, clearing the DTC using the Honda Diagnostic System, HDS, resets the onboard computer in the vehicle for accurate post-repair diagnostics. Once cleared, it is imperative to closely monitor the OBD status within the DTC's menu using the HDS. This will reveal whether the vehicle has passed the required tests and ensure that DTC P0716 does not reappear. If the HDS indicates a pass, this signifies successful repairs. However, if the test shows failed or not completed, further investigation into the electrical connections may be necessary, ensuring full restoration of functionality in the transmission system. Preventive maintenance plays a pivotal role in avoiding recurrence of DTC P0716. Regular checks of the torque converter turbine speed sensor ensure that it continues to provide accurate readings, essential for optimal vehicle performance. Scheduled updates of the powertrain control module (PCM) software prevent discrepancies that can arise from outdated systems that fail to communicate properly with sensors. Additionally, routine inspections of electrical connections and wiring help in identifying any loose or damaged terminals early, preventing faults before they escalate into significant issues. Implementing these maintenance practices is vital, not just for preventing DTCs, but also for enhancing the longevity and reliability of the vehicle's transmission system. In conclusion, DTC P0716 signifies an electrical issue related to the input turbine speed sensor A circuit. Any readings or performance problems from this sensor can indicate a failure of the electrical circuit rather than mechanical transmission issues, underscoring the importance of precise diagnostics. Awareness of possible causes, symptoms, and specific troubleshooting steps enables technicians to effectively resolve this DTC and restore optimal function to the vehicle. Implementing preventive maintenance measures is equally critical to ensuring long-term reliability, mitigating recurrence of similar faults. By adhering to these guidelines, technicians can enhance performance and extend vehicle longevity. DTC P0716 indicates a fault in the input turbine speed sensor circuit, specifically relating to its performance. The issue is strictly electrical, ruling out the possibility of mechanical failures within the transmission. The input turbine speed sensor measures the speed of the torque converter's turbine, which is essential for effective engine and transmission performance. This sensor is located within the transmission assembly, typically in proximity to the torque converter. A malfunction in this sensor prevents the engine control module from receiving accurate RPM readings, which may adversely impact shift timing and engine performance. Ensuring proper functionality of this sensor is vital for the overall performance of the vehicle. The possible causes for DTC P0716 are explicitly linked to electrical issues within the vehicle's system. An electrical circuit problem may arise from damaged wiring or incorrect voltage readings, leading to aberrant sensor performance. Loose connections between the torque converter turbine speed sensor and the powertrain control module (PCM) can contribute to insufficient signals being sent. Furthermore, a malfunctioning torque converter turbine speed sensor itself could produce misleading data about the speed, resulting in erroneous DTC readings. Each of these conditions must be thoroughly investigated to determine the root cause of the DTC and to ensure reliable vehicle operation. Symptoms associated with DTC P0716 can manifest in various ways. Drivers may notice warning lights illuminating on the dashboard, which commonly indicates transmission-related issues. There may also be noticeable performance problems within the transmission, such as hard or erratic shifting, which can impede the driving experience. A lack of smooth acceleration or delayed gear transitions can occur due to inaccurate speed readings from the sensor. Such symptoms not only compromise driving comfort, but may also impact the overall functionality of the vehicle. Being aware of these indications allows for timely diagnosis and repair, preventing further complications. The first step in troubleshooting DTC P0716 involves verifying the problem through a series of actions. Begin by turning the ignition switch to the on position or hitting the engine start-stop button to access the on mode. This step is crucial as it ensures that the vehicle's electrical systems are activated for further diagnostic processes. Following this, clear the DTC using the Honda Diagnostic System, HDS, which updates the vehicle's onboard computer, removing any previous fault codes. Next, safely lift the vehicle and ensure it is securely supported. This allows access to the undercarriage while ensuring safety during the diagnostic process. Lastly, ensure that the front wheels can rotate freely for subsequent tests. Completing this step prepares the technician to perform a comprehensive check on the transmission and associated sensors. In the second troubleshooting step, start the engine and disable the Vehicle Stability Assist (VSA) system by pressing the VSA off button. Disabling VSA is vital as it allows the technician to conduct a reliable test without interference from the stability control functions, which may affect wheel speed readings. After starting the engine, proceed to test drive the vehicle at speeds exceeding 19 miles per hour, 30 kilometers per hour, for a minimum of 30 seconds. This test is necessary to replicate the conditions under which the DTC was initially triggered, allowing for clear observation of the vehicle's performance related to the speed sensor. Upon completion of the drive, slow down and stop the vehicle in a safe manner to fully assess any issues. The results from this step are pivotal for determining the next phase of troubleshooting. The third troubleshooting step involves checking for DTCs with the HDS once again. This check will confirm whether DTC P0716 remains present after the test drive and is critical for understanding whether the failure is persistent. If the HDS indicates that DTC P0716 is confirmed, it suggests that the failure has replicated. However, if the DTC is not confirmed, this could imply an intermittent issue. In such cases, it is essential to investigate potential causes such as poor connections or loose terminals between the PCM and the torque converter turbine speed sensor. If the test indicates no other DTCs, it suggests that the system may be functioning normally at that moment. A thorough inspection of connections must be performed to prevent reoccurrence of faults. In this critical step, a thorough check of the torque converter turbine speed sensor is conducted. The technician should rotate the front wheels with the shift lever in D or drive gear while closely monitoring the torque converter turbine speed RPM and the input shaft drive pulley speed RPM displayed in the HDS data list. This allows for real-time data collection and assessment of the sensor's performance. Comparing the readings ensures that both speed values are closely aligned, as they should operate in tandem under normal conditions. If the speeds are about the same, it indicates that the torque converter turbine speed sensor is functioning correctly. However, significant discrepancies between the two readings warrant replacement of the sensor, ensuring the vehicle's transmission system operates as intended. If the torque converter turbine speed sensor is deemed functional and the readings are accurate, the next step involves updating the powertrain control module, PCM, software. Regular updates for the PCM are crucial, as outdated software can lead to performance discrepancies and erroneous readings. If updating does not resolve the issue, substituting a known good PCM may be necessary. A replacement with a fully functional unit ensures that the issue isn't originating from a malfunctioning PCM. After either of these actions, conducting repair verification is essential. By following up with the appropriate tests as described, the technician can validate that the DTC has been resolved and that the vehicle operates without errors. Please like and subscribe to the channel. See you next time.